Hello, I am Olalekan Badmus and this is my YouTube channel. So here you will get mathematics and science lesson videos, difficult concepts made easy through well explained and thorough methods of teaching. To get notifications from this channel, subscribe, like and share. Share to your neighbors, share to your friends, share to that student, share even as a parent to other parents. Who have students and children in secondary education. I want to assure you that you are going to get lessons that appeal to the understanding of your words, of your children, of your students, and even you as a student. Thank you. So in the last session, we saw what a segment is. A segment of a circle or in a circle. We saw what that is. And just to refresh your memory, I said that a segment is simply a figure that is bounded by a chord and an arc. A chord and an arc. Now that we've been able to describe a segment, now let's see how to derive the formula for calculating the perimeter of a segment. We're also able to calculate or to derive the formula for length of a chord. Length of chord, alright, and that's 2r sine theta over 2. 2r sine theta over 2. That's the formula for calculating the length of chord, right? Now, because we need to calculate the perimeter of a segment, perimeter simply refers to the boundary, alright, the boundary of a figure or of a shape. Now, how then do we calculate the perimeter of a segment, whether major or minor? Now, a segment is bounded by a chord and an arc. So when you think of a segment, right, think of a chord, then think of an arc. So this is a chord, right, and then this is an arc. So this is a segment. This is a segment. The space that is covered, right, by a chord and an arc is called a segment. So here, how do we find the perimeter of a segment? Perimeter simply refers to as boundary, as I mentioned earlier. So that means that we need to find the length of this chord, length of chord, and then length of arc, right? So perimeter of a segment, perimeter of a segment is simply the addition of the length of chord and length of arc. So to find the perimeter of a segment, simply add the length of chord, right, and the length of arc. So once you are able to do that, we have the formula for calculating the perimeter of a segment. So let's dive into that. The length of chord already is given as 2r sine theta over 2 plus length of an arc. We saw this much earlier, theta over 360 degrees times 2 pi r. Now, if you use this formula like this, well, you are going to get your answer. But to put this in a simpler way, right, we'll have to factorize. So observe, now this is one side of the formula, 2r sine theta over 2 plus theta over 360 times 2 pi r. Alright, so you observe and you see that 2r is common to both, to the formula in general. 2r, there's 2r here, alright, and there's also 2r here. So what we need to do is to factorize 2r. So by factorization, if you remember factorization in algebraic expressions and equations, now this is where to apply that. So 2r, if you factorize 2r and you divide this term, right, by 2r, right, where we'll be left with This is 2r, sorry, hold on, okay, 2r sine theta over 2, so we are going to have sine theta over 2 plus, now this also divided by 2r, we are going to have pi theta over 360 degrees, pi theta over 360 degrees. So therefore, perimeter of a segment is given as 2r into sine theta over 2 plus pi theta over 360 degrees. So that's the formula, and you don't actually have to cram it, all right? You can derive it by yourself and use it, right, by yourself. So let's check for some applied questions. So we've been able to describe a segment. We've been able to derive the formula for calculating the perimeter of a segment. So let's now see the application. So let's take an example. Find the perimeter of the segment of a circle of radius 14 centimeters subtending 104 degrees at the center. So we have to find the perimeter of the segment of a circle of radius 14 centimeters. So we have radius 14 centimeters, and then theta is 104 degrees. So let's draw a circle to represent that, right? So we have a chord, since we're actually calculating the perimeter of segment of a circle. So this is the center of the circle, radius 14 centimeters, right? Then angle 104 degrees, right? So to calculate the perimeter of segment, we use, let's say, perimeter of segment is given as 2r, all right? We have the formula here already, sine theta over 2 plus pi theta over 360 degrees. There is something I actually observed, all right, and that is theta on both sides, but you can as well use it like this, or better still, we can still go further. Actually, we can go further to improve on this formula, and I'm going to show you how to do that. All right, so the perimeter of the segment 2r into sine theta over 2 plus pi theta over 360 degrees. All right, now even though it appears as though theta is on both sides, but then it will be a little bit more complex. All right, so let's leave it like this. If we use it like this, we'll as well get our answer. So 2r into sine theta over 2 plus pi theta over 360 degrees. Now we have radius 14 centimeters, open bracket, right? Sine theta is 104 degrees over 2 plus pi is 22 over 7 times theta is 104 divided by 360 degrees. So what is left for you to do here is to punch your calculator. 2 times 14 is 28. This is 28. Divide this angle by 2. This will be sine 52 degrees. Then plus 22 over 7 times 104 degrees over 360 degrees. So punch your calculator. First, look for sine 52 degrees. Write your answer down, right? Once you have your answer, sine 52 degrees, plus what you are going to do is first write this answer down, then multiply 22 by 104. Get the numerators, right? Once you get the numerators, multiply 7 and 360. That will be the denominator. Alright? So once you are able to do that, you can then use your calculator, to simplify everything further. Alright, and you are going to get your answer. So I'm also going to do it here, and I'll write the final answer there. 28 sine 52 is 0.7880. Now plus 0.9079. Right, like I explained earlier, what you are going to do here is multiply 22 by 104, get your answer, right? Then divide it by open bracket 7 times 360 degrees. You are going to punch that in your calculator, and you are going to get 0.9079. So when you add this together, so we have 28, right, into 1.6959. So if you multiply these two together, 28 times 1.6959, that will give 47.485. So approximately 47.5 centimeters to 1 decimal place. So here we've been able to find the perimeter of the segment of a circle of radius 14 centimeters, subtending 104 degrees at the center as 47.5 centimeters. So let me know if this helps. If you have any question, you can use the comment section. Thank you. Alright, so I hope that lesson was effective enough to help your understanding and to help you learn better. I want to believe that you've gotten better than before. So if you have not subscribed, do well to do that. Subscribe, like, and share to everyone around you, so you